Hi everyone, welcome to our physics class. In the previous classes, we have studied kinematic equations of motion. The first one is V is equal to V naught plus AT. The second one is X is equal to V naught T plus of AT square. Third one V square is equal to V naught square plus 2AX. This is motion along a straight line, part 9. Okay, well, let's start today's class. So in this class, we are going to discuss about the next very interesting topic, that is relative velocity. So what is the meaning of the relative velocity? That is very important. So relative velocity, that is defined as velocity of one object with respect to another object. Definition is very simple. Velocity of one object with respect to another object. That is actually called the relative velocity. For example, here let us consider two trains. Okay, let's consider two trains. This is train A, and this one is the train B. Both are moving in parallel tracks with same velocity. Train A, train B, both are moving in parallel tracks with the same velocity. So velocity of train A, for example, 60 kilometer per hour. Velocity of train B, so that is also 60 kilometer per hour. So here the velocity of train A with respect to Earth, velocity of train A with respect to Earth, that is actually 60 kilometer per hour. So velocity of train B with respect to Earth, that is also 60 kilometers per hour. So velocity of train A with respect to Earth is 60 kilometers per hour. Velocity of Earth with respect to train A, that is minus 60 kilometers per hour. Is it not? Velocity of Earth with respect to train A, that is minus 60 kilometers per hour. So velocity of Earth with respect to train B, that is minus 60 kilometers per hour. So velocity of Earth with respect to Earth, that is equal to 0. This point is very, very important. Listen to me carefully. The velocity of Earth with respect to Earth, that is 0. But velocity of Earth with respect to train A, it is minus 60 kilometers per hour. That is moving opposite to the direction of train A. Velocity of train A with respect to Earth, that is 60 kilometers per hour. Okay, actually train is moving forward, Earth is moving backward. Okay, so while train is moving, Earth is moving backward. The magnitude of speed of train A, magnitude of speed of Earth, both are same, but the direction is quite opposite. Is it not? But velocity of Earth with respect to Earth, that is equal to 0. So velocity of train A with respect to train B, velocity of train A with respect to train B, that is VA minus VB. If two trains A and B moving along parallel tracks with same velocity, then velocity of train A with respect to train B, that is equal to 0. Why? Because here VA is equal to VB. Okay, if two trains A and B both are moving along parallel tracks with same velocity, then velocity of train A with respect to train B, an observer in train A with respect to observer in train B, that is equal to 0. Even the velocity of train B with respect to train A, so that is actually VB minus VA, so this is also equal to 0. So the velocity of observer in train B with respect to observer in train A, so that is equal to 0. But velocity of observer in train B with respect to ground, that is not equal to 0. That is 60 kilometer per hour. Okay. So actually, what is this? This is the relative velocity. So relative velocity means the velocity of one object, velocity of one object with respect to another object. What is the meaning of relative velocity? Velocity of one object with respect to another object is called the relative velocity. Okay, so here let us consider a graph. So actually this graph shows two objects are moving with the same velocity. So let's consider displacement is measured in terms of meter, that is taken along y-axis, and time is measured in terms of second, that is taken along x-axis. So this is the displacement time graph. So the slope of the displacement time graph gives slope of displacement time graph gives velocity. Is it not? So we have just imagined the two lines like this. These are the two imaginary lines. Okay, let's consider these 2 points are A and B, and these 2 points. This one is P. Let's consider this point as Q. So now calculate the slope. So what is the meaning of slope? Slope is the ratio of vertical distance divided by horizontal distance between 2 points on a straight line. The ratio of vertical distance divided by horizontal distance between 2 points on a straight line. Okay, so actually here the slope of the two lines, that is same. Okay, look at this diagram. Slope of this line and slope of the second line. This is line 1. This is line 2. Okay, so this is object A. This one is object B. So both objects are moving along a straight line, and both are covering equal displacements in equal intervals of time. That means both are moving with uniform velocity, constant velocity. Okay, so actually slope of the xt graph represents the velocity. So slope of this line gives the velocity of the slope of line 1 gives the velocity of object A. Slope of the line 2, slope is tan theta. Is it not? Slope of the line 2 gives the velocity of the object B. So here slope of line 1 and line 2 both are same. It means the velocity of object A and velocity of object B both are equal. So what is the velocity of object A with respect to object B? That is VA minus VB. So if VA is equal to VB, Velocity of object A with respect to object B is equal to 0. So what about velocity of object B with respect to object A? That is also equal to 0. VBA is VB minus VA, right? So that is also equal to 0. So this graph shows the zero relative velocity between two objects moving along a straight line with same velocity. So this graph clearly represents what? This graph clearly represents the relative velocity between two objects, that is equal to 0. Because here two objects are moving along a straight line with same velocity. Two objects are moving along a straight line with the constant velocity. Okay, the velocity of one object with respect to another object, that is exactly equal to 0. Now let us consider one more graph. Actually, in this graph, the relative velocity, that is not equal to 0. Here, one object is moving faster than other. One is faster moving object, another one is slower moving object. Okay, how do you find out which one is faster moving object and which one is the slower moving object? By calculating the slope of each line. Okay, so now consider here again two imaginary lines like this. So now calculate the slope of each line. This is the slope of the first graph. This is the slope of the second graph. So for both graphs, the change in time is same, right? Consider this point as A, this is B. These are two observation points on a straight line, line 1, and this is P and Q. So these are two observation points on line 2. Okay, so here time taken by the object A from point A to point B, and time taken by the object B if it travels from point P to point Q, that is same. Time taken is same, but the displacement is variable. So velocity is the rate of change of displacement. Velocity is directly proportional to displacement. Here the time is constant, right? So here the displacement of object, change in displacement of object A, it is more than change in displacement of object B. So that is why the velocity of object A is more than velocity of object B. So this clearly shows object A. So this is actually the faster object, and this one is the slower object. Is it not? So this is the faster object. So this one is the slower object, and the point of intersection shows. The point of intersection shows object A overtakes object B exactly at this location. At this location, object A overtakes object B. Okay, so in this case, the velocity of object A with respect to object B, that is VA minus VB. So VA is more than VB means VA minus VB, that is positive. And this is not equal to 0. This is not equal to 0. And velocity of object B with respect to object A, that is VB minus VA, so that is actually negative. This is also not equal to 0. So this graph shows zero relative velocity. This graph shows non-zero relative velocity. This is zero relative velocity. This one is non-zero relative velocity. Okay. So these two graphs are very, very important. So what is the meaning of relative velocity? So Relative velocity means very simple. The velocity of one object, velocity of one object with respect to another object. Okay, velocity of one object with respect to another object is called relative velocity. So when relative velocity becomes zero, if two objects moving along a straight line with same velocity, then the velocity of one object with respect to another object, that is exactly equal to zero. Okay. So the next topic, derivation of an expression for the relative velocity between two moving objects. First here, let us consider an object A that is moving with velocity is V. So here this is XA of uh, XA of 0. So this is the initial displacement of object A at time t is equal to 0. This is the origin. Object A that is moving along x-axis. Let us consider one more object, that is object B. Object B that is also moving along x-axis with velocity that is v. Let us consider xb of 0. So this is the initial displacement of object B at time t is equal to 0. Okay. Let us consider some initial considerations. At time t is equal to 0, xa of 0, so this is the initial displacement of object A, and xb of 0, so this is the initial displacement of object B. Xa of 0, this is initial displacement of object A at time t is equal to 0. Xb of 0, this is initial displacement of object B at time t is equal to 0. And at t seconds, xa of t, so this is the final displacement of object A after time t seconds, and xb of t, so this is the final displacement of object B after time t seconds. So how do you find out the average velocity of object A and object B? So what is the statement of average velocity? What is the meaning of average velocity? Average velocity is the ratio of change in displacement divided by change in time. So here VA is the average velocity of object A. The average velocity of object A is VA, that is equal to change in displacement of object A. So the final displacement of object A minus the initial displacement of object A, so divided by the change in time, is t minus 0. T minus 0, t is the final time, initial time is 0, t minus 0 is t. Okay, after cross multiplication, we will get VA into t, that is equal to XA of t minus XA of 0. So call this as equation number 1. That let us calculate the average velocity of object B. Average velocity of object B is xb of t minus xb of 0. This is the change in displacement of object B, so divided by what is the change in time, t minus 0 is t, the cross multiplication, we will get VB into T, that is equal to XB of T minus XB of 0, and call this equation number 2. Okay, after that, equation 1 minus equation 2, so that will give size to VAT minus VBT, that is equal to XA of T minus XA of 0 minus XB of T minus XB of 0. Okay, so right. So now here T is taken as common. So VA minus VB into T is equal to, so this can also be written in the form of XA of T minus XB of T. Is it right? Actually, this is the change in final change in displacement minus the initial change in displacement, that is XA of 0 minus XB of 0. Okay, so XA of T minus XB of T minus XA of 0 minus XB of 0. So call this as equation number 3. Okay, so XA of T minus XB of T. Okay, so this can also be written in the form of VA minus VB into T. VA minus VB into T. So plus XA of 0 minus XB of 0. So call this equation number 4. Okay, so change in displacement, change in displacement between two objects, change in displacement between two objects, that is actually equal to change in displacement between two objects is XA of T minus XB of T. XA of T minus XB of T minus XA of 0 minus XB of 0. What is this? Actually, this is the change in displacement between two objects. This is very, very important. Change in displacement between two objects is XA of T minus XB of T minus XA of 0 minus XB of 0. What is this? Change in displacement between two objects. So this is final displacement between two objects. This is initial displacement between two objects, and this one is the change in displacement between two objects. So XA of T minus XB of T. So this is final displacement between two objects. XA of 0 minus XB of 0. What is this? Initial displacement between two objects. XA of T minus XB of T minus of XA of 0 minus XB of 0. So this one is the change in displacement between two objects. So change in displacement between two objects, that is equal to. So what is the value of XA of T minus XB of T? So XA of T minus XB of T, that is VA minus VB into T, okay, plus XA of 0, XA of 0 minus XB of 0, right? Minus this one, that is xa of 0 minus xb of 0. Actually, your xa of 0 minus xb of 0, xa of 0 minus xb of 0. So get cancels. The remaining is va minus vb into t. Okay, so what is this? So this is the change in displacement between the two objects. Change in displacement between two objects. So, relative velocity of object A with respect to object B. Therefore, the relative velocity of object A with respect to object B, that is given by, is actually VAB. VAB is equal to change in displacement, between two objects. VAB is equal to change in displacement between the two objects divided by change in time, that is change in time. So change in displacement between two objects, that is VA minus VB, into T. So change in time between two objects is T. T minus 0, that is T. So T cancels. So finally we will get the velocity of object A with respect to object B, that is VA minus VB. Okay. So in similar way, the velocity of object B with respect to object A, so we will get VB minus VA. Okay, so this is the mathematical expression for velocity of object A with respect to object B, and this is velocity of object B with respect to object A. And this derivation is very important for 5 mark. Okay, so thank you.